Hey everybody, this is Larry. This is day 3 of the March Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Today is another rest day. Yeah, just ran hard back-to-back days, so today has been a rest day for me. In terms of exercising, I'm just also just doing errands today. Doing some shopping. Went to the library actually to kind of renew my library card. What did I do today? I think it's just a big resting day, to be honest. So yeah, so it was a good day. I feel slightly more rested. Oh, I got my jacket fixed. But yeah, let's take a look at today's farm. My apologies, I'm a little bit yeah, but that's okay. At 1545, find cave bit in nth binary string. Given two participants n and k, the binary string s sub n is formed as below. 0 and then some crazy things, right? So okay, so do an example. So 0, you have 0 plus 1 plus reverse of inward of 1. All right, well, okay, fine, right? Okay, so then now for the nth string we want to find the thing, right? Okay, so I mean, I think it just depends on it's going to be recursive. It just depends on, you know, because basically the idea here is like recursive, right? I mean, I just said that, but meaning that, okay, so then now let's say we have s of 3, right? And then we know that here immediately that the first, I don't know, 2 to the 3, 2 to the 2 minus 1, maybe, right? 2 to the 2 minus 1, maybe. It's going to be, it's the left side, whatever that means, right? Well, left side, whatever that means is that, you know, it is separated by 1 in the middle, right? In the middle, and then another 2 to something like this is the right side, right? So something like that, right? And then now, so we have to just find out, okay, if k is on this left side, middle, or to the right side, right? And then now, if it's, keeping in mind that, you know, for s sub I, the left side is s sub I minus 1, the right side is s sub I minus 1, reversed, inverted, whatever, right? So that's it. We just have to find the index in each of these and then recursively. I mean, you could also do it iteratively, but the idea, I mean, you can implement it iteratively, you can implement it recursively, but the idea is going to be breaking down in terms of itself, which is a recursive way of thinking, if not, you know, the implementation necessarily, right? Okay, so that's basically the idea. And I have to make sure that this 2 is correct. It's going to be just, okay, so for, oh, because it's, I was like, this feels a little bit off, but I guess s sub 1 is 1 index, that's why. But yeah, so, okay. So maybe we could do like while n is greater than 0, right? Is this the left or on the left, right? Oh, actually, I said I mean, it's still recursive actually. It's a little bit, maybe for me, a little bit easier, right? So let's just say f of nk, right? Okay, so then now we check, is k on the left, right? So you have, where's the numbers? Oh, only up to 20, but so then, okay, so this minus 1, if k is less than, I want to say less than, yeah. I'm thinking about less than or less than equal to, but yeah. Less than, then it's on the left. Then that means that we just return n minus 1, right? And then k, well, k is going to be on the left side, so we don't change the index. And also we have to do some like base case stuff, right? Okay, so then is k in the middle? Well, now that it is now on the left, we can re-index it, right? Then if k is the first number, then we just return 1. And then now, otherwise, it's going to be on the right. And on the right, we that means that we want to return some kind of something like this, but the new index is going to be different, right? Because, well, one is that it's going to be inverted. So the inverted, we do this, right? Because if it's 0, it gives 1. If it's 1, you give 0, right? And then now the reverse is the index that's reversed. So then now this is going to be power of 2n minus 1 minus 1. So then that's the number of things. So then if you revert it, so then it's this minus k, maybe plus 1. This one I'm not super sure on, just because I'm lazy. Let's think about it for a second, right? Okay, if k is, because if k is 0, this should be, yeah, so maybe this is minus 1 actually. If k is 0, yeah. This is the total number of things, minus 1 for indexing to convert to k index. I think this is kind of right, or close maybe, hopefully. I need to return a string version anyway, but clearly that's also not right. Let's make sure our base case is right. So yeah, is k 1 indexed? K is 1 index. So okay, so that at the very least is an obvious thing that we have to fix. But I could change n to index as well. So at least it fixed this part, right? We can also, like, do very basic things of 3, 2, 3, 3. So we have like all 3 strings, so we can check very easily whether this is all right, and this is all right actually. But yeah, and oh wait, no. This I was looking at S2. Actually, we want, yeah, S3, so we can test all 3, because or 7 or whatever it is, because yeah, then now we're testing both the reverse and the inverted, right? Because before we were not. So then now some of these should be wrong, and yeah, then we know. Oh, do I subtract? Oh, that's right. I actually meant I was like, did I do this? I meant to, but I forgot, because we checked that number, and then okay, there you go, right? So okay, so that was actually not that bad once we think about it, but I wanted to put the example case back. Was it 411, right? Looks okay, so let's give it a submit. Hopefully I didn't make silly mistakes. And yeah, and that's it. All you have to do is kind of, break it down one, they give you a recursive definition, so you just have to figure out where it lies, right? What's the complexity, right? Well, I mean, all the k stuff is going to be O of 1, right? In terms of k, and then n is, we just loop on n, if you will, because every time we do a recursion, n is 1 fewer. So this is going to be O of n, which is not linear, by the way. It's O of the number where n, which is exponential in the size of the input. But yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.